Hello friends, welcome to my channel. In this video, I will cover most important MCQs for engineering mechanics. These are useful for ISRO scientist, ISRO technical assistant, GATE and other PSU also. And these questions are from civil service and engineering service and GATE questions. Question is, consider the following statement: two couples in the same plane can be added algebraically. Yes, it's correct. Then coplanar and concurrent forces are the ones which do neither lie in one plane or nor meet at a point. It's coplanar. No. Concurrent means they should meet at a point. And next, non-concurrent forces are those ones who do not meet at a point. Yes, this is correct. A single forces may be replaced by a force and couple. Yes, this is also correct. So 1, 3, 4. D is your answer. Question is, two forces A and B acting at an angle theta, their resultant R will make an angle theta such that cos alpha equal to cos alpha value we have to calculate. Let two forces A and B, angle is theta and their resultant is R. This angle is alpha. So here draw a perpendicular. This is also B. This value is theta, so B sin theta here and B cos theta. We will number 1, 2, 3, 4 and 5. 4 to 5 is B cos theta, 3 to 5 is B sin theta. Then resultant cos alpha value we have to calculate. So cos alpha is, in triangle 1, 3 and 5, cos alpha is 3, 5 cos alpha. 1, 5 divided by 1, 3. Then 1 to 5 is A vector plus B cos theta plus B cos theta. Then your resultant R is 1, 5 square plus 1, 3 square. 1, 5 is A vector plus B cos theta whole square plus B sin theta square. Then root over. From this step also you can answer this question because no other B sin theta here, so not possible, only B sin theta, only C is possible. So if you solve further, you will get A plus B cos theta divided by B square cos square theta, B square sin square theta. You will get 1 sin square theta plus cos square theta. B square you have to take common. Finally, you will get A square plus B square plus 2AB cos theta. You can cross check your answer. A plus B cos theta divided by A square plus B square plus 2AB cos theta. C is your answer. Question is, if the maximum and minimum resultant forces of two forces acting on a particle are 40 kN and 10 kN respectively, then the two forces in the question would be how much? So R maximum, R value we know, it's P square plus Q square plus 2PQ cos theta. It's root over. So R square if you do, R square equal to P square plus Q square 2PQ cos theta. In this question, R maximum means cos theta equal to 0. Cos theta will become 1, theta is 0. Then R maximum is 40 kilonewton and R minimum is 10 kilonewton. So 40 into 40 or 40 square is P square plus Q square plus 2PQ. Cos theta will become 0 when R will maximum, and it will become -1 when R is minimum. So 10 into 10 P square plus Q square minus 2PQ. Cos theta is -1. You add both, you will get 1600 plus 100, 1700, 2P square plus Q square. So P square plus Q square 850 kilonewton. Then from options we have to check 25 square is 625, 15 square is 225, you will get 850. So A is your answer. You can cross check others also. B, it's 400 plus 400, so B not possible. Then your C, 200 square is 400, then 100, you will get 500, so this is also not possible. Then D, 20 square is 400 and 5 square is 25, so 425 you will get. D also not possible, only A is possible. A system of forces acting on a lamina is shown in the figure. The resultant of the force system will meet AB at a resultant position you have to calculate. So here we will take moment along B, because 10 Newton and 10 Newton both are collinear with B. This line they are collinear, so it's easy. Taking moment along B, it's equal to 0. Clockwise is positive, so 10 into 1 minus 20 into 1.5, it's equal to 0. We'll get 10 minus 10, it's equal to 0. So the resultant force system will meet at B point only. B is your answer, because we are getting moment at B point, it's 0. So B is your answer. Question is, two forces act at a point. The first force has X and Y components of 3 Newton and minus 5 Newton respectively. The resultant of forces falls on the x-axis has magnitude of minus 4 Newton, and xy components of the second force is how much? So first let the first force is A. A is having x component 3 Newton and y component it's minus 5 Newton. The resultant of these forces falls on x-axis, so resultant is R. X-axis means Ry value will become 0. So Rx is 4 Newton. We have to calculate Bx and By. B is the second force. Bx and By, x component and y component we have to calculate. So we know Ax plus Bx equal to Rx. So from here Ax is 3 plus Bx equal to Rx is minus 4 Newton. So Bx equal to minus 7 Newton. Then in y direction, Ay plus By it's equal to Ry is 0. So Ay minus 5 plus By it's equal to 0. By will become 5 Newton. So minus 7 Newton and 5 Newton. A is your answer. Question is, the inertia force in a system is directed at inertia force. We know inertia force F equal to minus ms. So 180 degree to the acceleration. D is your answer. List 1 and list 2 matching. Two parallel forces acting on a body moving with uniform velocity. First we will take B1, a moving particle. It should have kinetic energy. So fix B with 1. Then see two coplanar forces equal in magnitude and opposite in direction. Equal in magnitude and opposite in direction means they will form a couple. So C you fix with 2, B you fix with 1. Then from option we have to check C with 2 and B with 1. B with 1 here, C with 2. Here B with 3, C with 4, so A not possible. Here 2, C with 1, so B also not possible. 4 and 1, D also not possible. C is your answer. You can cross check A with 3 and D with 4. A with 3 means two parallel forces acting on a body moving with uniform velocity. Parallel forces, uniform velocity means forces in equilibrium. Correct. Two unequal forces acting on a body causes acceleration. Yes. C is your answer. If a point A is in equilibrium under the action of applied forces, the values of tension TA, TAB and TAC are respectively how much? So at A point first we will take in x direction. For equilibrium of A point, Fx should be 0. Forces, all forces along horizontal direction, they should be 0. So TAB cos 60 is root 3 by 2. It's equal to TAC cos 30 is 1 by 2. So TAB divided by TAC you will get 1 by 2 divided by root 3 by 2, you will get 1 by root 3. Then along y direction at A point it is equal to 0. TAB into sin 60 is root 3 by 2. Sorry, I put the angle mistake value. So again I am doing Fx. If you do TAB by TAC you will get root 3. And along y direction, summation of all forces along y direction it's equal to 0. So TAB into sin 60 plus TAC into sin 30 we will get 600 Newton. W is 600 Newton. So TAB we will write TAB into sin 60 root 3 by 2 plus TAC. From here TAC we can write TAB divided by root 3 into sin 30 is 1 by 2, it's equal to 600. So better we can write it in TAC form. So TAC we can take common TAC root 3 3 by 2 plus 1 by 2, it's equal to 600. So TAC equal to 2 into 600 divided by 4, you will get 300. TAC is 300 and TAB is root 3 into 300. Here I will do TAB equal to 300 root 3 is 1.7. You divide 10, it's 510. So from option we will check TAB is nearly 510. So here 520 is available and TAC it's 300. So A is your answer. Question is, what is the thrust at the point A in lamp post shown in the figure? So two components you make, one into sin 60 this direction, 1 into 1 kilonewton into cos 60. So thrust at A point it's due to 1 into sin 60 only. 1 into sin 60 is root 3 by 2. So again approximation we have to do. Get no problem, they will provide calculator. But in other exams you have to do in approximation only. 1.7 by 2, 1.7 by 2 divide 10, 217 by 2 is 8, it's 8.5 divided by 10, so 0.8. It's approximation, so approximately A is your answer. Question is the force F such that both the bars AC and BC are equal in length. AC and BC, C point is here, AC and BC both are equal in length, identically loaded as shown in figure. We have to calculate force F value. F value we have to calculate. So AC cos component and BC cos component both will same. So along x direction we will calculate. At C point along x direction for equilibrium it should 0. Then right side we will take positive F BC, this side F AC. So right side we will take positive, left side we will take negative. So right side is FBC, let this is theta 1, this is theta 2, FBC cos theta 1 plus 100 kilonewton into cos 45 degree minus FAC cos theta 2 minus F equal to 0. We know both are same and 60 degree, these two, so their value will same. So FB cos theta equal to FAC cos theta 1. You can cancel them. Then F equal to 100 into cos 45 degree. 100 into cos 45, 1 by root 2. So 100 divided by 1.41. So all are above 100. So B you can cancel, C cancel, D also you can cancel. It's equal to 70.7 Newton. A is your answer. Question is, in the given configuration of the mechanism as shown in the figure, VA equal to 40 meter per second and VB equal to 30 meter per second, the magnitude of velocity of slider B relative to slider A is how much? So B value is VB 30 meter per second and VA equal to 40 meter per second. So VBA we have to calculate. VA square plus VB square root over. VA is 40 square plus 30 square root over 50 meter per second. C is your answer. Question is, a horizontal force of 200 Newton is applied at A to lift the weight W at C as shown in the given figure. The value of W will be how much? So if you take at B point, fulcrum moment along B point, clockwise you will take positive and anti-clockwise you will take negative. First W into 0.075 minus 200 into 0.3 is equal to 0. So W equal to 200 into 0.3, we can write 3 by 10 divided by 0.075 or 75 and 10 to the power 3. So here 25 8, it's 100. So D is your answer, 800. A uniform heavy rod AB length L and weight W is hinged at A and tied to a weight W1 by a string at B. The massless string passes over a frictionless pulley of negligible dimension at C as shown in the figure. If rod is in equilibrium at horizontal configuration, then W1 and W relation we have to calculate. At C point, it's frictionless pulley and string is massless. So this direction W1 and T, tension in the string, it's T here, so this side also it's T. And at B point, this is B point, this is C point, B point also, it will become tension T equal to W1. Then here TBC equal to W1 we get. Then its weight is W. At midpoint it will act L by 2, this side L by 2, this side L by 2. We have to calculate the relation. Both are L and L. So this angle is 45 degree. So taking moment along A point, it's equal to 0. W into L by 2. It's clockwise, so positive, minus TBC into sin 45 into total length, it's equal to 0. So if you calculate LL cancel, W equal to TBC is W1. This is TBC. It's equal to W1. So W by 2 equal to W1 by root 2, or this question W1 equal to root 2 by 2 W by root 2. So D is your answer. Question is, a weight W is supported by two cables as shown in the given figure. The tension in the cable making an angle theta will be minimum when the value of theta is how much? So T1 value is minimum when this is W, weight is W, this is 90 degree, this is also 90 degree. So this angle is 90 plus 60, it's 150, this side 90 plus theta. This angle is 180 minus 60 plus theta. So apply sine rule. T1 divided by 150 degree sine 150 degree, it's equal to T2 divided by sine 90 plus theta, sine 90 plus theta, it's equal to W divided by sine 180 minus 60 plus theta. Or this one also we can write it in 90 plus theta term, sine 90 plus 30 minus theta. So from here T1 is inversely proportional to sine 90 plus 30 minus theta. T1 is minimum, so this value is minimum, means this term it should maximum. Sine value is maximum at sine 90 degree, so theta should minimum. Theta should minimum means, so this complete term it should become 90 degree. 90 plus 30 minus theta, it's equal to 90. 90 you can cancel, theta equal to 30 degree. This is your answer. It's better if you remember this one. Theta is equal to 30 degree because this question is repeating. This is the end of this part. Thank you friends. Thank you for watching my video. Thank you.